Welcome to developing real-time web apps used with the ArcGIS API for JavaScript. My name is Javier Delgadillo. This is my colleague, Ricardo Trujillo. We both work on the real-time GIS team. In his spare time, Ricardo also does some spatial temporal data store development. First off, I'm going to start off with a little overview of the ArcGIS Enterprise and real-time and big data capabilities. So as many of you may or may not know, the real-time capability allows you to ingest high velocity and real-time data into ArcGIS. This means you can sort of go out now and get desperate random sorts of data and bring them into the ArcGIS ecosystem and then perform various tasks on it, sort of like continuous analytics on the events as they are received. So as you're receiving events from the field, you can now go in and look at their geometry, look at attributes, and take actions based on those things all in real time as they're happening. And then in addition to doing that analytics, you can also store them out to your data stores, whether that be a spatial temporal data store or maybe another existing feature service backed by Oracle or the out-of-the-box Esri SDS data store with Postgres. And then once you've got it stored in your data store, you can now run analytics after the fact using the GeoAnalytics extension that just came out at 10.5. So now you can sort of, in real time, you can make some decisions as things are happening, or you can sort of store the information for later use and do analytics after the fact. And so what we're finding now is that people are actually trying to use this capability to integrate their IoT deployments, which sort of explodes the number of observations that are coming into the system at any one point in time. So what we had to also do was come up with better ways of visualizing data that's just massive when you're talking in scale of volume and just sheer amounts of observations. So what we did is in the spatial temporal data store, we added a way, some logic so that if you've got too many observations on your extent at one time, you can aggregate them into bins, whether it be by hexagon, triangles, or some other mechanism. Now you can sort of get a raw count inside of that bin about how many observations are there. And then as you scroll down into your view, then you can start seeing the individual records once it's sparse enough that they're not all on top of each other. And then, of course, after you've done all of this analysis and whatnot, you can also sort of decide, I'm going to notify somebody that something happened as I saw these events, whether it's in real time saying, I'm going to send an alert because I noticed a vehicle went into some area of interest, or after the fact, I did some analysis and now I'm seeing there's some sort of trend going on that I hadn't noticed when these events were coming in real time.
So as Javier mentioned, one of the challenges with ingesting large amounts of data at high velocities is the ability to visualize that type of data in a meaningful way. Here at the real-time team, we have kind of two methods we use for visualization. One of them is the stream layer kind of push approach, where we're pushing observational data back to clients, whereas it could be a web map or a device or a custom app or even desktop. Well, we'll stream the observations back up in a push mechanism. Couple advantages of that is the ability that you don't really have to store that data. You're just getting what's actually happening kind of right now. It's your current dashboard view, which is kind of neat. Low latency depending on the velocity, but there's some drawbacks where you don't really have that playback capabilities of something like the spatial temporal data store. The other method that we use is actually our traditional map and feature services, but when they're backed with something like an enterprise geodatabase or the spatial temporal big database, we can actually then do the pull, where we pull for your data every second, every couple seconds to get your latest observational view on your client apps. One advantage of that is now you can retrieve your data and do analysis on it. You're storing that versus the stream layer where you're not storing your history of that observational data. With the introduction of the spatial temporal big data store, it gave us a huge advantage where we can store large amounts of data and actually then play that back in a meaningful way. And what we're going to show you is actually how we leverage the spatial temporal big data store in our map services using an aggregated map service, and how we visualize millions and millions of point data in a very fast, efficient way. And then, of course, like Javier mentioned, we can actually run now at 10.5, leverage the spatial temporal data store to run more analytics, batch analytics, using the GeoAnalytics server.
All right, so now we're going to get into how you actually would visualize this in a JavaScript API-based web map. So for this section, I'm just going to concentrate on the stream layer approach, which is the approach which Ricardo mentioned, where the GeoEvent Server pushes features up to a client, and so the client, it's up to the client to render those features in a meaningful way. And what I'm showing here right now is sort of the basic required elements that you're going to have to add to your JavaScript app. This is, of course, this is assuming that you guys all know how to create a JavaScript app, a web map, and if you don't, come talk to us afterwards and we'll show you more of the details. But assuming you've got a web app that already knows how to display a map, a traditional feature service back map or a map service back map, you just need to add these 3 lines right here. Make sure that I have access to the stream layer, and then the Dojo DOM ready that says, okay, I'm sort of done. And then once you've got that inside of your JavaScript application, you just need to add something, basically what amounts to these 4 or 5 lines right here. So the first line is just a URL to the REST endpoint on the ArcGIS server that represents the stream service, right? For any of you who've ever done work with a feature service or a map service, that'll look very familiar. The only difference is at the very end it says stream server instead of map server, it's a feature service. And then I'm going to create a JavaScript object for a stream layer, and then eventually add it as a layer to my map and my JavaScript application. So that's sort of the basic things you need to do just to get a stream layer to show on the map. So now what I'm going to go ahead and show you guys is some, get your power.
It's fine.
Okay. I'm going to show you guys some sample apps that I've got deployed up on GitHub that you guys can play with later, and then you can click around with as well. Is this mirrored or do I have to? Okay, it's mirrored. So this is the portal for my GitHub project. All right, so you guys can go to this after the fact. Are we putting the slides up? I'm not sure. So if you want the slides, you can come give me your card afterwards, and we will email them to you if you want the links for this, so you guys don't have to rush and write it down or anything. But if you come here, there is a link in the middle of the README that will take you right to this page right here, which just has each individual page linked to it from there. So I'm just going to take a real quick time to show you what is basically this basic stream layer app. And if I go back to the source code, you'll see that I'm referencing this stream service out here, out in the wild, which if I go to it over here, it's basically the stream service that's running out on a sample server on the internet, which is available for you guys to play with if you guys want to write some test apps. And when I click the subscribe button, you'll see that what's coming through is just raw feature JSON. So this web page is acting as a client to that stream service, and all it's doing is echoing the JSON. So that's not very interesting. So what we're going to go do is see that once I've got this stream layer down here.
We should zoom that in. Zoom that in.
Is it too small? Can you guys read that?
Zoom it in.
Control plus.
Yeah, there you go. That's better.
That's better?
Yeah.
So now once we add the layer to the layer, now we've got some other methods that are standard JavaScript API methods to handle events and add get the stream to start going. So what this is doing, it's just listening to a feature service that's replaying satellite positions around the planet. So as soon as I start this, you're going to see the dots start showing up. And I can actually click on if you let me click on one at the bottom so that I can see the whole pop-up. But it's got all the attributes in there. And so that was a very simple sort of hello world type feature service example that you can do to just get dots on a map. But what if I wanted to do something a little more interesting? one of the other nice features about the JavaScript API is it lets you sort of add a listener for all of the events that come through. So I can take an action on an event by looking at its attributes. And the way this works is by, here's the process, here we go. On the stream layer itself, you can add events. So right here, you see there's same stream layer on. If there's an error, it's going to call this function and just log the error. But what I'm interested in is every time I get a message, I want you to call this process message method. And what all that method is doing, it's looking at this attribute called the bus number and saying if its value is greater than 3,500, I'm going to increment the greater than count. If it's less than, I'm going to increment the less than count. And then all I'm going to do is I'm going to put that into the UI to show. So basically on each event, I'm taking an action and I'm going to do something in the UI to correspond to that. Let's see, let me scroll this down so you guys can see it. So I'm just going to start this stream, and as soon as the dots start showing up, you can see the counters sort of start updating. And this is based on every event that's coming through. So this gives you the flexibility to make your apps as responsive as you'd like them to be based on the events that are coming through. See? And with that, I'm going to pass it back to Ricardo.
All right. Let's back up. Thanks, Javier. All right, so then I'm going to be showing you guys a couple of apps that we have actually developed that actually use the spatial temporal big data store's map service and feature service, which does aggregation on the fly using big data. So we have a GitHub project here that, again, like Javier said, we can share these links with you guys later so you guys don't have to rush and type them in. But you can leverage these apps to explore some of the really neat rendering options that we have available for the spatial temporal big data store map service feature service. So let's go. All right, so what you're looking at is a really simple JavaScript app that we added here. And then what I want to do is I want to point to my regular feature service, map service. This is a map service I have hosted here on my laptop. Right. And then let me just open that. I think I have it open right here. Yeah, so here's my map service called Flights. I've had it populating with some flight aware data over the last couple days, just kind of populating this data set with flight data. And what I wanted to do real quick is to show you the count of this data set. So I'm just going to do regular REST query, return count. You can see we have over, it's kind of hard to see, but over 22 million points there. All right. So now if I go back to my little app, I'm going to go ahead and set the layer. What that does, it actually calls the map service export, just loads it. Again, the first thing you'll notice, it's not points, right? Even though it is, the underlying data is points, but we've come up with these different visualization techniques to visualize that amount of data on a web app or any other client you have. And what's really cool about this is we're actually aggregating on the fly the bins. These are geohash bins, but every time we zoom in, it's actually re-aggregating on the fly. This is meant for like your streaming data feed, so the counts get updated. And you see how responsive that is real quick. So just zooming in. As I zoom in, the detail of the bins gets smaller, so you kind of know where the hotspots of your data is. So the cool thing about this app, though, that I wanted to display is we can actually play around with some of the aggregation settings and styles that we have exposed. So one thing is also we can change the aggregation style. Right now it's geohash. We can do something cool like flat hexagons, where we actually show more the honeycomb hexagon feel here. And we have other ones like square. You might ask why square? They look like geohash. Well, square is more of a uniform square versus a rectangle for geohash. That's why. And geohash are based off WGS84, whereas these squares, you can actually target a coordinate system that you want your base maps in. We can mess around with the bin size. We can say, okay, let's increase the bin to 20 and make the bins bigger. We can turn the labels off, so you can just see the bins there. We can change the colors. This is really interesting here, the feature threshold count. In this map service, if we can set up this parameter called feature threshold, and we can set a number. Right now it's set to 1,000, where if in your map extent, if I zoom in and the raw feature count is less than 1,000, it actually shows the raw features, which is kind of cool. You can play around with that depending on your data. And knowing that, you can actually then start configuring like your simple marker symbol for these points. You can go in here, like one of the ones I like is this pointer one. You can click on this pointer one. Let's make it a darker color. And then one cool thing we also have here is we can set up rotation based on a field of your data. So we can say rotate the symbol based on a heading, because flights have a heading. So it's kind of cool. The cool thing though is this is actually based off your raw feature count in this extent. It's not really like a scale dependency renderer. So if I just pan the map, all of a sudden I get the bins, because in this map extent, it actually has a feature count greater than 1,000. So that's kind of cool. Pretty neat, huh? So that's the map service. So that's one. And just to show you, if you download this app from the GitHub page, the code that you would really need, there's a lot of boilerplate code in the sample. But yeah. So what I wanted to, what did you say? Is actually what you need to do to enable all these really cool aggregation settings is you add this new aggregation renderer that we've enabled for using the JavaScript API. But the other things are just like adding a typical map service. You just add a dynamic map service layer to your web map, and that's it. It's pretty simple like that. So the other one I wanted to showcase is the other GitHub repo is actually this. This is a feature service. This is consuming the data from the feature service, the raw data. It's not really doing the map export on the server side. It's actually bringing back the aggregation bins here on the client, on the JavaScript side. And actually, you can request now at 10.5.0, you can say, okay, feature service layer or map service layer, give me what we call LODs, to give me the raw bin geometries or the bin center points or the geohashes, however you want your app to display the aggregation, plus the counts, or you can even do statistics as well too. So right now, all I'm doing is actually querying the backend feature service for all the bins, and it's actually getting that, rendering them here. Very similar like the map service, this one, we can just play around with some of the settings like the LOD level, what LOD level you want to display your map in. You can just change that. One thing I like though is because we're using the power of the JavaScript API and the full power of the WebGIS, we can actually do something like use some smart renderers, and we can do some heat map. That doesn't look so nice, but the granular, the more bins we get back, you can start seeing the shape of the heat map, which is kind of neat. Kind of a different way to visualize your big data, right? You can see if this query comes through. The more LODs, the more bins you're bringing back, so it's more data being fetched and brought to the client side. It's taking a little longer. Yeah. I think that's all I got. Is that it? Okay. So let's go to the. All right. So I think we just wanted to bring up this slide to let you guys know some of the more the real-time sessions we have offered later today and tomorrow. We'll be doing another one more in detail about that big data, spatial temporal big data store in a few minutes, actually, over at the Catalina Madero, yeah. And, yep. And I think that's it. If you guys we'll open it up to questions. If you guys have any questions or any other feedback. No? Thanks, guys. We'll be here.
We'll be here.